In this video, we are going to highlight tips, tricks, and procedures for changing the window of your graphing calculator. If you simply press graph, you are given what the graphing calculator refers to as its standard window. You'll notice that the x-axis goes from -10 to 10, and you'll notice that the y-axis goes from -10 to 10. Because the calculator is wider more than it is taller, you'll notice that the spaces that are in between the numbers on the x-axis vary a little bit. That's just the calculator's best attempt at showing you accuracy all the way across the x-axis. As you use the calculator for more complicated techniques and tricks and calculations, you'll probably want that to be a little bit more exact, but the purpose of this video is just to outline how to make very generic changes to the window so you can see all of the relevant parts of a graph. If you click the window button at the top of your calculator, that is where you have the option to make changes. You can change the minimum x value and the maximum x value to make that horizontal axis go wider or narrower. And you can change the y minimum and the y maximum so you can see more top to bottom or less top to bottom. The scale numbers, so x scale and y scale, are how the calculator are going to count the numbers that are along each axis. So because both of these are set to 1, these tick marks on each axis represent 1. If I was to change the x scale to 2 and graph, now they're only showing me every 2 lines. Depending on the graph that you have and the amount of space that you're trying to show, you may need this number to be significantly larger than 1. Imagine you're showing an x minimum of 0 and an x maximum of 1,000. You don't need to see every individual mark. In fact, the calculator doesn't have enough room to show you every individual mark. A good rule of thumb when in doubt is that the x scale should be a divide by 10 of the length of each of these axes. And same thing for the y scale. So if the x minimum and the x maximum have a distance of 20, the x scale could be 2. 1, 2, 3, somewhere in that range. There's no hard and fast rule that says the scale has to be a particular amount, but taking the length of the axis and dividing it by 10 is usually a good rule of thumb. Not to say that it will work perfectly like that every time, but it's not a bad idea. It'll give you some basic generic marks, and you'll at least have an idea of where key fluctuations in a graph might be. For the purposes of this exercise, I'm going to switch this scale back to 1. Let's go into y equals and actually try to graph something, and we'll do some manipulations of the window. The function that we're going to graph is x squared minus 3x plus 2. And if you press graph after you type that in, you get a parabola. Now, some of the key characteristics of the parabola are a little bit guarded by the creation of this graph. I can't exactly tell. I think it's between 2 and 3. This intercept here, I definitely don't know where the vertex is. It looks like it's below the x-axis, but I can't tell exactly where it is. Over here, I'm clueless as to where that y-intercept is. So because all of these points are so close together, this would be a good candidate to adjust the window, zoom in a little bit, and see if I can get those points a little bit more accurately. Because most of the interesting information happens on the right side of the y-axis, I don't need much in the way of the negative space for the x-axis. So for the sake of this example, let's change this to -2. I don't need to go much farther than that. I'm going to be able to see the y-intercept. I'm going to be able to see both x-intercepts. I can narrow this in a little bit and not go all the way out to 10. I know the interesting stuff was kind of happening all less than 5. So let's change this to 5. The scale, I can leave this at 1. Because this is such a small region, our divide by 10 theory doesn't really work for this one. So -2 to 5 is 7. If I divide that by 10, it's 0.7. I'm counting by 0.7s. I don't want to do that. So I'm going to leave it at 1. And I definitely want to bring the y's in. There wasn't much interesting happening in the negative y space. So we're going to say -3 here. And then in the y max, there wasn't much happening interesting beyond 2 or 3, so maybe we'll go 5 here as well, and then I'll leave that scale the same. If you're wondering what the rest of these numbers do, these last 2 calculations deal with the resolution of the graph. I do not recommend changing them at this time. They deal with how accurate the graph is and how, as you get more and more use out of your calculator, you may want to experiment with these numbers a little bit, but I don't recommend changing these at this point. This work is typically automatically generated based off of the information that's typed in elsewhere in the calculator and what it knows about the function, so I would leave this alone for the time being. But since I did change my x max and my x min and my y min and my y max, I can take a new look at my parabola, and I have this much better view of the parabola. Now, ideally, I would zoom in a little bit more. That certainly looks like it's crossing it too. I could zoom in a little bit more and try to get those points pinpointed. But what you'll see in a later video is that the calculator has strategies built into it, techniques built into it, processes built into it that allow you to find these points exactly without you just having to eyeball them. So while I have a guess as to where this might be and where those two might be, based on what I know about parabolas and based on the information that's given to me by this graph, I certainly don't have that information exactly just yet. So I would want to make sure that I maybe used one of the other processes in the calculator to determine those 3 points accurately, or some other algebraic technique.